This is the Redwall Limestone, probably the biggest cliff forming unit in the Grand Canyon. Definitely one of the most imposing topographic features in the canyon. If you were going to try to hike in or out of the Grand Canyon, the cliffs of the Redwall Limestone would definitely be a huge obstacle to getting in and out of the canyon. The name Redwall Limestone is interesting because as you can see here beneath my feet, the rock is pretty gray. It's almost uniformly gray, more or less. But when you see it in the cliffs here, it has more of a reddish look to it. And that's because the units above, the Supai group and the Hermit Shale, are kind of that brick red color. And when they get flash floods and thunderstorms here, that actually kind of coats the Redwall Limestone with the reddish muds from above. So the coating of the red on the rock is just kind of a surface feature. When you actually bust down through that very thin veneer of red, you can see the rocks are actually quite gray. So this is a limestone, and we're going to look at it up close. Here down on the Grandview Trail at Horseshoe Mesa, the Redwall Limestone has a really special surprise for us. I want to show you here at the end. But let's start with sort of just the context for this unit and its depositional environment. So the Mississippian in Western North America and really around the world was a period of high sea level stands. And so the ocean was high. The Grand Canyon region here was near the equator. And so you can see that throughout much of the west with this light shade of blue, this is all shallow water. So when you look at Mississippian aged rocks in the western US, they're almost always limestones or dolostone carbonate rocks that were deposited beneath the ocean. So we had, a few patches of land and some uplifts here, but, most of Arizona was underwater, Utah, Wyoming, Colorado, much of the Intermountain West was underneath the shallow tropical seas. And at the time of the Redwall Limestone deposition, with warm tropical waters and all of the shallow water, there was a lot of organisms living in those oceans. And so the Redwall Limestone typically has a lot of fossils in it, invertebrate fossils, things like clams, different types of shelly organisms, coral, that sort of thing. And so when we look at the Redwall Limestone, again, it's this big imposing cliff in the Grand Canyon. But we're going to look at here, we'll look at it up closer and then I'll show you some of the surprises. So I haven't seen any fossils in here, but limestone in the west where it's dry tends to form big cliffs. In fact, when you look at the Grand Canyon, all your big cliff faces are either sandstone or limestone. The other rock types that form the slopes tend to be much softer, things like shales, mudstones, that sort of thing. So the limestone here, if we look at it here, it looks, pretty typical. But as we come down this little slope here and look at the limestone, it looks a little different in terms of color. It's got kind of a yellowish hue to it. It also looks like it's really fragmented and beat up. We call this, when rocks are just broken into fragments that are angular, this is what we would call a brachiated limestone. It's fragmented and kind of beat up a little bit. And what's actually happened here is something pretty cool, and something you don't find everywhere in the Grand Canyon. Is limestone is a soluble rock, which means when it rains, the slight acid in rainwater and in groundwater dissolves the rock out. So this is the rock type that we typically see that forms caves and sinkholes. So after the Redwall Limestone was deposited, sea level dropped and this layer was left high and dry. And of course, it was over time covered by other layers. But the point is that when this was elevated and exposed, the rain and the harsh climate started to dissolve it and form cave systems within the Redwall Limestone. And as it got buried by other layers like the Supai group and the Coconino sandstone, the water kept moving, the groundwater kept dissolving and moving down through the Redwall Limestone. And because it had formed these cave systems or these sinkholes, there was these conduits where water could move through it pretty easily. It had fragmented and brachiated the rocks as these caves formed and as these sinkholes formed. If we fast forward a little bit to maybe about 200 or so million years ago, maybe in the Triassic Period or the early Jurassic period, there were volcanoes in the western US that were starting to erupt, and so this area got blanketed with ash periodically. And as that ash percolated down with the groundwater into these brecciated zones, it actually concentrated deposits of copper and uranium in the rocks. And you can see as you look around at some of the rocks here on the ground, these really cool bright green colors. In places there's kind of like a sky blue. Even these darker black ones here, these are concentrations of copper, uranium, maybe some other metals as well. And early prospectors who came down here in the late 1800s saw these rocks, knew that they might contain valuable metals, and actually worked to get equipment down here. We can actually see an old piece of mining equipment that was brought down, you know, maybe over 100 years ago to work these rocks and see if they could profit from them. And I think they did extract some amount of copper from here, but ultimately it was just too expensive to ship it out of here and just such a burden. So here's one of the collapsed, one of the adit tunnels, and some of the, well, it's what's left of it anyway, collapsed in. But you can see near the entrance here, this beautiful green copper rich rock just splashing on the faces of it. Here's some with that kind of sky blue. That's called Azurite. This is a copper carbonate, and this is malachite, also a copper carbonate. These beautiful copper minerals just splashed on different faces of the Redwall Limestone. Another one here with some of the really brilliant blue and green colors in there as well. So we'll go down to one more little face here. It's like some rocks on the ground with some of the copper in them, but also you can kind of see it here, just splashed on the rock itself, coating the faces along these fractures within the Redwall Limestone. So cool little story here down the Grandview Trail in the Grand Canyon, a story of oceans depositing limestone over a period of time, that limestone forming cave systems, sinkholes, which provided good conduits for groundwater to move through, getting buried by progressively younger layers, some volcanic ash, then concentrating the copper in these rocks, and then a short little mining history here that went up until I think the early 1900s here in the Grand Canyon. The Redwall Limestone, one of my favorite units in the Grand Canyon.